Hello, everyone. We are live with our episode 29 today, and we have Professor Alan Smeaton as our guest speaker. And we are thrilled to have him on, genuinely. And Alan, please introduce yourself.
Good morning, good afternoon, good evening, good night, wherever you are and whatever time it might be. My name is Alan Smeaton. I'm a professor of computing at Dublin City University in Ireland, where I've been for quite a while. My background is originally it was in information retrieval, text-based information retrieval, and then into multimedia and video analysis and computer vision, and then more generally, artificial intelligence and language models. I'm a professor of computing, so I do the usual stuff in terms of teaching and research projects. And I've also spent most of the last year actually as being a member of the Government of Ireland's AI Advisory Council, which I find to be absolutely fascinating and very rewarding. That enough, Elena? That's my introduction.
Sounds wonderful. I have so many questions about your latest role on the advisory council, but yeah, that's for
Okay.
a later conversation.
Right.
So,
Ellen, thank you so much for joining us I know it's evening in your part of the world, but and thank you for suggesting such a really interesting topic, because I think that with all that talk about AI generated videos, content, it's been, I think this year has been highlighted by those kinds of discussions. But I think the other aspect that we wanted to focus on today is that while you're producing all that content that people are consuming, how do you make your content more memorable, relevant, kind of getting to the point, and what kind of techniques are out there to actually achieve that goal? And Ellen is going to, share some secrets with us today. And because you have been in this space for quite a while now, and you've been on quite a journey, I hope you'll be able to share that with us as well. And also how to use some of the machine learning and AI techniques to kind of process these videos, evaluate these videos, this content, so that the audience are kind of more captivated, if you will. And also based on your kind of teaching experience, I think that's also very relevant, because these days, people are, professors, teachers are trying to engage, students, to engage audiences with all the different kind of techniques that were not even available back in the day when I was in college. So we're off on a very interesting start. And Ellen, back to you.
Yeah. So let me give a little bit of context and background. And when I did my PhD, this isn't a life story now, but the hot thing at that time was information retrieval, which was text search, where you type in words and then we matched against databases on collections of text. And then came the web, and that became a very popular topic. And we had search engines like AltaVista and Lycos and Ink2Me and Ask Jeeves and what was that other one? Oh, Google. That was another one. Yeah, remember that? And that became a very hot area. But one of the things that I became a little bit discouraged about was the fact that big tech companies were owning the very, very large collections. And if you wanted to work in a university or in public research, you were working with very small collections because you didn't have access to the resources that the big tech companies had, or the data sets and so on. So I started to look at other media. And at that time, video was just becoming available on computers. Now it's just a sort of widespread, and it's assumed that it was always there. But we were just getting to the stage where we had compression algorithms that could take very large raw video files and reduce them to the stage where you could actually store them on a DVD and play them back. And at that time, computer vision was all about analyzing the content in order to achieve compression, to make the file sizes smaller so it could fit on DVDs, and then after that so it could be streamed over the internet. And I became interested in computer vision, not to do not to do file compression, but to take the content that is in that video, and in particular the visual part rather than the audio part, to analyze it and to provide mechanisms that could allow subsequent searching and browsing. And the first of those was really very, very simple. If you're looking at a post-produced video, not like this. This is one long shot. This podcast. But if you're looking at anything that's produced, like a TV advertisement or a movie, or many of the content that is available to us online, it's made up of individual shots. So back in the day, what we were doing is we were trying to determine where is the boundary between one shot and the next shot. So what we could then do was, within a shot, we could extract one representative frame and represent a video as a collage of images. So you take a 30-minute episodes of Friends and you'd see it as like 200 or 300 individual shots. And that would allow you to go, oh yeah, there's the scene there, and I'll click on that, and then you'd be able to jump to it. And that was the way that video was analyzed. And that was the high water mark for it, was basically in order to be able to structure it or decompose the structure in order to allow it to be navigated. And that really got me into the area of computer vision. And I then started to look at other ways in which we could analyze the content in order to provide captions, in order to provide tags, in order to provide descriptors, and then ultimately to then use those as a way to then go and navigate and search and find. And we take this for granted now. We just go to very large archives, we just type in keywords, and we expect to get ranked list of the video clips that we're looking for, just all nicely sorted. But that journey to that has been based and built on the back of the techniques which we call computer vision. Now, at that point, most people would then put a full stop or an exclamation mark and say, that's it, that's the end of computer vision. But there's been so many other applications of computer vision that have spun out from that in the last few years. And many of them are very well known and popular, like autonomous driving of cars. And many of them, or rather a very small subset of them, are very much under the radar. And that's what I think I'd like to talk about this evening, which is in particular the idea of video memorability.
Yeah, can you share that amazing Google anecdote with us?
Yeah, I was gonna say that.
I was kind of looking forward to that one.
You brought this on yourself during.
Yes.
You mentioned that, and we'll let it go.
They have minds like steel traps. They never miss a thing, those two, Elena and Alina. So way back in the day, this would have been a couple of decades ago when Google was just started, and its focus was on text-based search. We had reached the stage in our technology where we were able to take video from broadcast TV or movies, which had been post-produced into individual shots. And we were able to identify the shot boundaries, even if they were gradual transitions. So normally what would happen is you'd have a frame, and then you'd switch to another camera or another angle, and it'd be frame. And it would be adjacent frames that would mark the boundary between. But sometimes if it was a post-produced movie, you might have a gradual transition from one frame into the next. And that might last over half a second, which is 12 or 13 frames. And we were still able to do that fairly reliably. And we were able to take content, broadcast content or post-produced content, structure it into a collage and allow people to search for images, which was the searching through keyframes, and then to be able to go and find, jump into that. We made a visit to Google in California, and we gave a brown bag lunch, I think is what they called it, to about 150 employees. And I'd say there was only a couple of hundred people working in Google at the time. While they were all munching, having their sandwiches, and we were up there demonstrating how we were able to capture content, analyze it, structure it, and et cetera, and say, this is the stage that we're at. And we weren't trying to sell anything, except ourselves, I suppose. And at the end of a very long day of meetings, they came to us at the end and said, thanks very much for your presentation, but Google isn't really interested in video. Yeah, right. And then about 3 months later, they bought YouTube. So I don't know whether they bought it as a result of us or as influenced us. In my mind, I like to think we had some impact on that, but then the rest is all history. So that's the story. We didn't get anything out of it, except it was a nice trip and it was a good chance to go and meet colleagues and friends who work in Google. So yeah, that's the anecdote.
This is a great story.
So I have shall I share the slide deck that I have?
Oh, sure. Yeah, I think we're going to probably, it's a good segue to kind of start focusing on kind of video analysis benchmarking and like video memorability. Yeah, so let me stop sharing this, and yeah, you can take the stage.
How's that?
Perfect.
Good. And I know there'll be a bit of latency when I go from slide to slide to slide, and I hope that the video works, the video embedded videos that I play. So defaulting into university professor mode and going into lecturer mode, as I am. So the areas of analyzing video in order to be able to identify shot boundaries and content was one of the earliest applications of machine learning. And I would claim that most of the advances, the innovations that have happened in machine learning, which have impacted so many other aspects of our lives, most of those have come from the computer vision area. I would say that the exception to this is probably what we would call machine learning at scale. Machine learning at internet scale was developed by Google and in support of their AdWords product. But the rest of the machine learning, the rest of the innovations and the developments of support vector machines and K-nearest neighbors, and in particular neural networks by Geoffrey Hinton, all came from computer vision. And the task at that time was really to just take content and to see what's in that picture, what's in that video clip. And all of the neural network work that was done in computer vision. And computer vision is and has always been involving analyzing and understanding images and videos and using that analysis to then do something like make a decision. So if it's a CCTV video footage, then you make a decision on making an alert as to whether that's an outlier event. Or if it's ordinary content, then a decision as to what the content, how it may be tagged or how it may be described. And as the third point there illustrates, there's widespread application for computer vision. You know, we see these now. We open up our iPhone and we get face recognition in order to have it unlocked. We have self-driving cars. We have driver assistance. We have parking of cars. We have facial manipulation, facial recognition. We have deep faking. We have adjusting facing. I mean, one of the things I did, neither of you would need to do this before coming onto this, is that there's an option to adjust your face to make it look even more right. So I confess,
you're wrong assuming that we didn't do that.
No, I am.
Okay. I'm sorry. Now you have to tell us, what did you adjust?
I adjusted. There's a pop-up, and I know it's the same in Team and in Zooms, which is to adjust your the quality of your face, so it gets rid of all the blemishes. So I really have loads of warts and blotches, but it just gets rid of it in the video. So these kind of things are in our everyday, and they're all basically computer vision. And some of the glamorous ones are those, but there's also the ones in the background, like monitoring CCTV in order to detect anomalies, which are genuine anomalies and not just sort of tumbleweed going across a yard, that kind of thing. And the computer vision applications in medical for analysis and diagnosis of X-rays and scans and MRIs and stuff like that. In agriculture for monitoring crops and everything. From retail for product monitoring. In entertainment and media, all of that sort of stuff. There's loads of applications of computer vision, and it's probably the application of artificial intelligence, i.e. the application of machine learning, that is most used. It's got the greatest number of use cases. And the basis for this is that it's attractive because it does whatever that task might be. It does it faster than a human can do it, and it does it more reliably, and it does it replicability, right? And that it just replicates again and again, and it's consistent. And even if it's slightly off in its output, it's consistently slightly off in its output, and therefore it's reliable. And for a long time in computer vision, I suppose the target or the high water marks were trying to detect an object and to recognize an object. And in computer vision, we love pictures of cats, right? So trying to detect, is this a picture of cat? And is it a picture of, or not a picture of a cat? Does this photograph or does this video have a cat or a horse or whatever it might be? And it was object detection, and then object naming and labeling was the task. Alicia,
why the cat? I have to ask this.
I've no idea. It's one of those things that
in computer vision,
yeah,
lab or something?
it's, I suspect it's because cats have visual features that are quite distinct compared to other animals, and by that I mean the
Not
pointies
dogs,
and the whiskers and
not canine species. So interesting. Yeah, because
too
I love
many.
both. I'm one of
Yeah,
those weird people who like both cat and a dog person, but I would wonder why specific. I don't have anything against that, but it's just curious.
I
Curious thoughts.
suspect, yeah, I suspect it's not dogs because there are so many dog breeds and they all look different to each other. Whereas with respect to the cat that you have there, a cat is a cat is a cat. And although there are different breeds of cat, they all look much more similar to each other than do dogs. So that would be my only guess as to why it is cats. And then once it started and it stuck, and everybody stuck with sticking with pictures of cats because everybody else would be doing pictures of cats. As I was saying, a lot of the time in computer vision, through the history of computer vision, the task was to detect an object and to detect the silhouette of an object like this and to extract it from its background, which is actually working right now because I have my background blurred. And as I move, right, that is object detection that is working in real time. For a long time, the idea behind that is that you could detect the silhouette of an object and extract it from its background in order to compress the video. So in this video, this part of the video frame, my face is moving because I'm but the background hasn't changed. And if you want to transmit that over a network, you just transmit a picture of the background because there's nothing moving in the background. So there were the motivations for computer vision to do compression and to remove the necessity of repeatedly sending redundant information such as the background. And after that, then we then moved on to be able to identify objects, to identify activities, right? So, like juggling, right? Like that, okay? So and I can only juggle 2 balls and one of them has fallen already, right? But so to be able to detect not just an object, so this is a face, this is whatever the background, this is a juggling ball, etc., but to detect the activity that is going on. Like that. And that became the task after we became very good at doing object detection and labeling, then became the task of doing activity detection and activity labeling. And then became the task of doing captioning, which is to describe what this video is about. And if you can take any shot from an advertisement or social media post or a TV or a movie, then describe what is happening in that individual shot. And we've got to the stage now where we got that pretty much done. We can do that really reliably with standard computer vision techniques and even more accurately and reliably with the recent emergence of language models. So we're pretty good at doing that. And that might lead to the supposition that, computer vision solved. End of. Right? We can take stuff, we can just analyze, we know what's there, we can do it accurately, reliably, at scale. What is there left? And I would contend that there are the most interesting of problems still remain to be looked at. And in particular, now we're getting on to the topic of today, which is computer memorability. So on screen, what you're seeing are 2 video clips, and they are on loop, repeating. And the one on the left is basically somebody opening somebody's eye like this. And the one on the eye and the one on the right, which I hope it transmits okay to people when they're watching this, it's a shot from one of those gory detective series where it's the camera is moving inside the body and identifying the location of a bullet lodged somewhere inside. So it's phantom. When we consider memorability of video, we consider video with which we have no emotional content or connection. So it's not video of your families or friends or places or the Empire State Building or anything like that. It is emotionally neutral, although this is a bit emotionally inspiring, this stuff that we're looking at. And if you have enough people looking at that video, and then you ask enough people in a scientific environment whether they recall that, then you will find that those 2 videos have an intrinsic property, which is their memorability. any idea, either of you, which of those two, left or right, is more memorable than the other? What do you think, Elisa?
To me personally, the left one, when somebody's opening the eye, is more
Yeah.
memorable, and I can tell you why, because the association
Okay.
that I got is from the Clockwork Orange.
Ah, okay.
Yeah,
And
yes,
Alina, which one would you think? Left
because
or
the
right is
movie,
more memorable?
yeah, the movie basically
Left.
mentions the name,
Yeah.
Yeah, left does it for me. I like these are
So,
beautiful eyes.
and by memorability, that means that if you see that video once and then you see it an hour or 3 hours later, anything between 1 and 3 hours later, will you remember seeing it from all of the videos that you might have seen? That's short-term memorability. And there's also longer-term memorability, which is, would you remember it a week later? And the scores for those two videos, this is where we have the drum roll. Ta-da! You're both correct. The one on the left is far more memorable than the one on the right. And this is, you'll find that in individual cases, individual people may remember the one on the right more than the one on the left, but generalizing across a population, across hundreds of people, they're the scores associated with that. And it's an intrinsic property of those videos. So for about the last 6 or 7 years, we've been working on a task, which is to computationally replicate the calculation in a number in the range 0 to 1 of how memorable or forgettable a video would be. We've run this task annually, and the idea is that we follow what is the typical information retrieval and the computer vision template of shared synchronous benchmarking. What's that? Well, you take a collection of data and you make this available to the research community. And the research community then downloads that and does whatever they need to do. And then each member of the research community, each lab or each group which participates in this annual activity, then submits its results to the central control center, right? The coordinator. So we might have 1 or 5 or 10 or 20 or 100 different groups participating. Everybody runs their own media memorability prediction algorithms and sends the results back to the shared coordinator. The coordinator then gets this input from all of the participants, right? And they don't see each other's, examines them, calculates the scores, and then tells each group how you performed, and how you performed. And that model of doing shared synchronous benchmarking has been around in information retrieval and in computer vision for 3 decades. That's how it works. We have standard collections. We take them, we run our different algorithms, we submit them, they get evaluated, and then you find out how you fared compared to other groups. And it's not a competition per se, as in there's winners and losers, because everybody who participates is a winner, because we all learn which techniques work and we learn which techniques don't work. And that's as important. And in the case of memorability, we have a collection of videos, 10,000 of them. They are 3 to 5 seconds in duration. They have a memorability score, which is in the range 0 to 1, but you'll see what the distribution looks like that. There's very few really, really memorable ones. There's a hell of a lot of really forgettable ones, and then most of them are in this range here. And you can see from the worked example there it could be, there's one video of which I've just taken out 3 shots. It's a video of somebody crumpling up a dollar bill and then pretending it looks like a chicken laying an egg. And that is so memorable. It's 0.99 in the memorability in the histogram there. And then you've got some other ones of just an ordinary panda just chewing on bamboo, because that's what pandas do. And that's not particularly memorable, but it's down in the 0.091 range, etc. So what we know is that we have the ground truth for these. The participants don't know the ground truth values. They're given those blind. They then calculate what they think are the memorability scores, and then we compare them against the ground truth. And as a result of that, we have a deeper understanding about how memorability and ultimately about human visual memory works. So, how am I doing so far? Any questions? Will I just keep going?
Yeah, I have a question.
Good.
So can this technology be transferred? You know how they say like, oh, he or she has one of those faces, they're like not memorable. You see that person once and you'll never remember the face again. Other people, you see once and you just remember that face. Can this be like this memorable face predictor?
Yeah, that's
If
a really
anybody might want to be scored by that algorithm, be like, okay, do I have this memorable face or not? I don't know. People are weird. They might be interested. If there was an app, for example.
yeah.
I just gave
I
someone
don't
an
know.
idea. I know it.
Yeah, you have actually. You've given me, and I'm trying to think of what a good answer to that. And I suspect so. None of the content in here, right, that you can see, except for maybe this guy's face, etc., is it leverages the memorability of that face on its own. What is memorable
Mhm.
about that video clip, whatever it is whatever he is doing and whatever the background might be, and whatever however the camera moves. But the memorability or the forgetfulness of a particular face is something I don't think I haven't seen anybody looking at. But there's nothing you can do about it, Aline. You can't change your face. You can just
Oh, you totally can
Yeah,
with
yeah.
sufficient amount of funds, Alan. You go to
This
Turkey,
is such
you come back with a different face.
this is such an interesting business idea. I am now thinking about dating apps, Alan.
Okay,
I've
and is
never.
it?
I mean, I come from a generation where there was still no internet, like no online dating, because But I know that many people are using those apps, and some been very successful and things like that. So, Elena, that's a great idea. So we're just coming up with some, like a pitch.
So which do you want to have though, Elisa?
Alan, we need to go to Google one more time next time. We're doing this.
Yeah, I'm back 20 years later. I'm back.
Yeah, go to Silicon Valley.
Yeah. Okay, I'll go on to the next thing then. So this is a sample of 1,500 of the videos that we would take, and the whole collection has nearly 1 million human annotations, which means every video has been annotated for its memorability. In other words, somebody has sat down and been shown a stack of videos, one after another, after another, after another, including the ones that are being used for evaluation, and then has come back an hour or 2 hours later and has gone through them again and said, yeah, I remember seeing that one. No, I didn't see that one. Yeah, I saw that one. And those then are accumulated and aggregated up to give the memorability score for each of the videos. We typically extract 1,500 of them for evaluation. Their nature of them is that they're diverse and they adventure everyday videos. And you can see how the ground truth is shown in blue, and then the calculated scores from different algorithms basically tracks what that ground truth is, and the closer it tracks it, the better. So we were interested in algorithms. We developed algorithms which would have processed the video, analyzing the content, not to tag it and not to come up with a caption, but to rate it in the range 0 to 1 in terms of its memorability. And every year we would compare results from each other. Somebody would have a technique that they introduced that was, got them a little bit of an improvement. And then the next year, everybody else would have used that technique. And that's the way that worked for about 4 or 5 years. We all learned from each other. And as a result, the collective field improved to the stage where we are now able, and this isn't just our group, but every other participating group pretty much, because it's so shared and so open, is able to take short form video clips and to be able to compute that memorability in a range 0 to 1. And we left at that, and we're thinking, great, now the next thing is to move from we've been able to demonstrate something scientifically to how can we use it. And I'm going to give you 3 examples where we, in our particular research group, have been able to take this underlying technique and technology and then apply it to different things. And the 3 approaches are video cropping, video in painting, and then analysis of a TV series. So the first of these is video cropping, and video cropping it's taking this frame. If you can look at mine, if viewers can look at my screen, it's taking my frame and just cropping it around typically my face. So you wouldn't do a crop which cuts my face in two, but this is a thing that's a post-production technique that you take sub part of the window because you want to focus attention. And you might do this if you're taking your photos that you've taken with your camera and you haven't got time to do the zoom in. So you'll just take a broad shot and then afterwards you'll do the cropping just to take the nonsense background out of that. And that particularly applies to content which is created from a phone, because we don't, it's hard enough to find the video play button or the snap button without also zooming and then tracking, etc. So it's a post-production technique that is most useful for videos and pictures taken with these. But this platform doesn't support this. It's very awkward to do the cropping because it's time consuming and you don't get any prompts or any assistance. So what it does, though, it focuses and it contextualizes viewer attention. And it's a balancing act, because if you're to just focus, if I was to just crop with just my face, and I don't want to frighten your viewers by just going all over like that, then that would be too much. And at the same time, you don't want to have too much of the background, because then you lose the focus. So it's a balancing act. And during the playing of a video shot, you can have a fixed size crop, or you can vary the size of the crop in midstream. And you can have it at a fixed location, or you can have it moving in the location. So there's a lot of parameters associated with cropping. And I use this example here as an example of a post-produced video, which is absolutely perfect in its cropping. Now, you'll recognize Magnum PI from about the 1980s at some point. And I deliberately ended the clip there because I don't want to give away as to whether Magnum was shot by a nun on a ladder. That's a really weird thing to say or not. But you see how that worked was brilliant, because it focuses on Magnum, Tom Selleck, it focuses, and then suddenly you see the nun in the background, and it's you almost don't realize the amount of zooming in that there is on him and the tracking of him that is happening in the way. So what we were interested in doing was in seeing if cropping a video could enhance its memorability. Now, in the studio, in the post-production studio for Magnum PI, they did that, and they would have enhanced the memorability by focusing on what the action items were. So one of the ways you can do this is that you can run an algorithm on video, and it will run in real time, which basically looks at and determines the most salient parts of that video. So on the top and on the left here, we see here's a video shot, and they're looping around, and it's a couple of people doing, surfing a wave. And associated with that, you can see in this pane here, the heat map of where is the most attention, the part of the video frame which grabs the human eye most. In other words, where would people's eyes be looking at if they were looking at that video? And you can see when it loops around, it starts and it's looking at the surfers, and then our attention is drawn to this breaking wave. You look at this part here, you'll see there's a dot there, and then it breaks up here. So our attention is drawn to the wave. And if you were to do cropping around that, then you should include the people who are doing the surfing, and then broaden it to include the waveform. In the second video here, this is even a better examination, or an example rather, of how saliency can move within a frame. So what we see is that somebody's jumping from a rock into a pool. And at the beginning of this, if you look at this here, you'll see there's multiple points of interest. And then when it gets to the end, we're only interested in him in the water. So again, the cropping of that would be a combination of broad and then ending up with something small. And then the last one, the family on the bicycles, is fairly neutral, because it's just a big blob in the middle, because we're watching the three of them, four of them on bikes, and we're not particularly drawn to anything, and that's just the nature of this. So in our work on the video memorability by cropping, we used saliency to determine where the crop should happen around these boxes. And we ran it on the large collection of videos in an attempt to see if we did variable sized cropping or fixed size cropping and variable location cropping. In other words, it moves around, or fixed location cropping. We did all sorts of combinations of those. And eventually we found that what happens is, and this is shown in this graph here, here's all the videos from 0 up to 1500, and anything with an orange or a red line shows it disimproves the video memorability, and anything with a blue line shows it improves the video memorability. And these are sorted by the original ground truth of what is the memorability on the scale of 0 to 1 here. And what this tells us is that there's an awful lot of blue down this end, which means that if you give me a bad video, then our algorithm will improve its memorability. Unfortunately, if this end here, because there's so much red and orange at this end, it says that if you give me a good video in terms of memorability, we'll ruin it for you. So the end point or the end result of all of this is to say that what we can do is we can take bad videos and improve their memorability. But for videos that are already good memorability, there's nothing more we can do, because this is nothing more that it can be done. So that was the end point of that piece of work. We weren't discouraged by that. We were intrigued by that. So you can improve the bad ones. And there's no point in improving the good ones. Well, what happens if you then, instead of cropping the video, if you outpaint the video? Now, that's something different. So outpainting is a technique, and it's shown in this still image here, where you take an image and then you generate, using generative AI techniques, what the rest of that above and below would have looked like. So this is the original video, and this, the video, it's a video frame, and this is what it looks like when it is outpainted. So anything above this line here, all of this stuff here, is generated from generative AI. And anything below, you can see in the original, it's just above the knee. So anything below the knee here is generated by generative AI. So what we did was we used two techniques, off-the-shelf, standard, state-of-the-art techniques for outpainting of videos to see if we could improve their memorability. And we tried all combinations of outpainting sort of north and south, outpainting east and west, outpainting north, south, and east, west. We tried it by various amounts and ran lots and lots of different variations. And in each case, we would compute the memorability, or know the ground truth memorability of the original one, and then we'd see what the result looked like when we had done the outpainting. I mentioned that we had two techniques we used. This was one, and these are so recent. These weren't around in 2021 or 2020. This is a consequence of this huge interest in the speed of development of computer vision associated with language models. That was the first technique we used, is that one there, which is called M3DDM. And then the second technique is called Motia. And you can see what it does is the difference between the two is that the Motia one uses the salience of the original image as well as a description of its content. So it takes this original video frame, which is of a baseball stadium, and you can see that the north line, the upper line there, is just above where the two sets of floodlights would be, and then the line here is just where the person in the red top would be, and then down here you can see, you know, it increases this by adding more sky, and then it broadens it. It actually broadens it out this way, sort of left and right. And you can see that in this one here, it ends at the stadium, whereas in this one here, it has generated, for some reason, this building here. There's a better example shown in the next slide, where we can see the original video with its boundaries, and then we can see the outpainted results there. And another technique, another variation of that would be like that. And the results we got for this were exactly the same as with cropping. We can take a really poor video in terms of its memorability, we can outpaint it and improve its memorability. But if you have an already good video in terms of its memorability, then outpainting doesn't do you any good. And again, we weren't disappointed by that result. We were intrigued by that result, because it left us in a position where we now know that we can take a video, a bad video in terms of memorability, and we can improve it if that is what we wanted to do. I'm going to stop there because I've been talking for quite a bit, and I'm going to ask you to see if there's any questions you might have.
So I do have a question regarding this particular scenario. So for this memorability rating, you were saying that the outpainted one, the last one, the quadrant with the AI-generated building, actually got the higher score than the original one?
Sometimes it does. If the original one has a low memorability score, then outpainting will improve its memorability.
Yeah. And in this particular scenario, I think you showed the scores. I think that they were pretty close. To me personally, I would say the original one is more memorable, because I find the composition, just kind of, it just really gives you kind of that feeling of being in a baseball field. I don't understand why I want to be looking at some other like building on the side. You know, like the original picture here, video, to me captures the essence of what's happening, right? So I'm kind of intrigued by the results if the if the last one on the right actually got the higher memorability score. It's kind of interesting. Well, or maybe it was I mean, the difference was negligible in this particular case, but it's just kind of curious.
And I mean, I'll throw back at you your own words. It's a very immersive. This one here, the original one, is a very immersive video because you can see there it's the event, but there are memorable things added in the outpainting, like this extra scoreboard and this building, and it's those that may trigger an increase in the memorability of that. And we also have here, I mean, we have the grass has been cut off with just a couple of swathes of that, light green, dark green thing. Whereas here, it has been outpainted very faithfully to have a lot more grass associated with it. So by adding more content to it, that may be a reason why the memorability of the outpainted one is slightly more improved. Also, we also have in this particular outpainted one, we have more clouds. And one of the phenomenons that people have is a thing called pareidolia, which means that we see faces in clouds, whereas there may be something memorable or recognizable in the cloud structure. And this is all fake. This is all generated artificially. And so also is the building here. But the outpainting may introduce things which are not in the original, which improve its memorability, or it could be the reverse. But the point is, it changes the memorability. Yeah.
Question. So if the image on the left was real, right? It's just the real image, is just cropped. And we've extended that image and added some clouds and everything and the screen. So the person might end up with the memory of a totally different image. So basically you're doctoring people's memories, and the person will remember, I remember there was a beautiful day, the clouds and the screen and everything was like so beautiful and the grass was green, blah, blah, blah. But that has literally almost zero to do with the original event that was taking place. So originally the concept of photography and everything was like to preserve the memories, to preserve like everything. But going forward, is that even going to be a thing?
Yeah.
Like who's gonna be able to tell the truth apart from not truth?
Yeah, it's an extension of the idea of false memories. It's false content to induce false memories. It's deliberately feeding and generating false content to improve the memorability by creating false memories of things. So if Elisa remembered this one here because of the building, right? The building that wasn't there. So yes. But what we're doing here is we're pushing back the boundaries. We're seeing what's possible. And we're not yet at the stage where we're introducing this into any algorithms or any products or any services and stuff like that. We're seeing what the boundaries of what the human memory can recall. And it's these false content which is superimposed on top of this by the outpainting, which intrigues us and allows us to explore what makes some things more memorable than others. Yeah, no, I'd be frightened if I saw this available as a product to take, your TikTok videos and outpaint them and make them more memorable as a result, because you're introducing false content there.
I pretty much think that's that's our not distant future at this point. It's pretty much set to be our reality. I don't know. I'm a pessimist when it comes to this.
I don't know if there would be a huge amount of interest in taking this content or this technique and applying it to social media videos in order to improve their memorability by introducing and doing outpainting, because it doesn't work reliably enough. It'll do the bad stuff. It'll improve the bad stuff, but not consistently so. And we still don't know the difference between with those that it does improve by much and those that it improves or disimproves by. So we still haven't investigated or determined what are those characteristics.
But someone might think I'm pretty sure it's gonna help my content go viral like every single time I post. So therefore, I'll just try and do something every time with my content. So for people might go as far as doing that. So social media going viral. I don't know.
You think, And that's the lovely segue into the third application and the third thing I wanted to talk about. It's almost as if that was teed up, Alina, but it wasn't. So anyway, so yes, what we did was we take content, we applied the two algorithms for outpainting, and then we see what it looked like. And then we were interested in applying it to something, not TikTok videos, not social media content, not to doing that. We were particularly interested in analyzing not just a video shot, but a long series of video shots, which makes up a program. And the content we focused on were the first 5 seasons of CSI, Crime Scene Investigation, the original ones from 2001 through to 2006. And your viewers maybe and listeners may be into, why did you choose that? We chose those first 5 seasons, 38 episodes, each of about 40 something minutes, because somebody else had annotated every shot and every scene with who was present, whether it was the victim, whether it was the killer, because it was always a killer and a victim in CSI, whether it was an action shot, all of those kind of things. Somebody had manually annotated all 38 episodes in painstaking detail of who was on screen. Was it Catherine? Was it Grissom? Was it whoever it might have been, etc. So we knew we had something to map the memorability against. And what we did was we took all 38 episodes, so you're talking more than 30 hours of video. We determined the boundaries between every one of the shots, and there'd be about 1,500 shots in an episode. We then determined the memorability for each shot, and we were able to analyze the memorability of each shot in the context of what type of shot was it? Was it an action? Was it the victim? Was it the crime scene? We also did it in terms of characters. Was it Grissom? Was it Catherine? Was it either, or was it both of those? And we came up with the real insights. Now, we would have thought that if you have a 45-minute episode of something, then in order to make it more memorable, what you want is those killer scenes, the morgue scenes, the discovery of the bullet, the discovery of the big revelation of, who done it, that kind of things. So we particularly focused on where was the memorability of shots in those sequences compared to the rest. So we focused on this crime drama, this whodunit series, and we were particularly interested in the memorability around shots where the killer was revealed, and the mechanism for the killer, because it isn't, with CSI as with many other TV programs, it isn't just, it was she who did it or it was him who did it, but it was, how did they do that and how did they nearly get away with it? We're interested in the backstory behind that. So that was the how did they do it type of thing. And then the last thing that we were particularly interested in, associated and extracted from the storyline, was why did they do it, right? And the trying to backfill the storylines and see how memorable were those clues. Now, if you think of an episode of CSA or any crime drama, you get to the end point and now you know the killer. And then you always turn to whoever you're watching the TV. I knew that was her because she did such and such a thing. I saw her hiding the gun under the pillow, right? And that was now I see. So hiding the gun under the pillow, was that memorable? Or was it not memorable? You want it to be not memorable. The director wants it to be very forgettable because you don't recall that until, now I get it. So there's a playing around with the memorability, and you want the memorability in an episode of crime, of a crime drama, to go up and down like a roller coaster throughout the episode. And for the parts which give away the clues, you don't want them to be memorable. And for the other stuff, the entertainment value, you do want them to be memorable, because then when you get to the end, I should be going this way, right? And when you get to the end of the program, it's only then that you can recall the clues that have happened throughout the program. And we found there were consistent patterns with different directors. So of the 38 episodes, they were directed by 4 different people. And I think Grissom was one of them, and the actor who plays Grissom was one of them. And each director had a different style, had a different memorability curve. So there's almost like a personal fingerprint for directorial style. I don't think they knew what they were doing in terms of memorability, they were doing something, they didn't know it was memorability, and now retrospectively we've been able to piece that together and say, they were doing things which made some scenes and some shots more memorable than others, and therefore that contributed to the overall episode. So it's a fascinating insight, and as far as I'm aware, it's the first non-benchmarking type application of video memorability to retrospectively analyze 38 programs in a whodunit crime drama to see how the storyline corresponded to the memorability of shots.
Yeah, I'm just wondering. I mean, you have been teaching for a while, so have you used any of those techniques on your students for your lectures? And because we have, I mean, as teachers, like professors back in my day, there was like a blackboard and a piece of chalk, right? No PowerPoint, no laptops, no computers, nothing. So it was like a one kind of actor, kind of a theater, right? So now we have so many different tools just to trying to grab people's attention. So maybe it's a secret sauce. You don't want to spill it out. That's fine. But I'm just, because I think that in education it gets so important. We hear like students are bored. They're not reading. They're not engaged. They don't care, about learning stuff. And I would be curious from your professorial perspective.
In the face-to-face lectures, the theatrics doesn't give you much scope. So the only thing you can do to make a lecture more memorable for students is to frighten them. And by that, what I would do is as well as staying up at the front of the class, quite often what I would do is that I would then go and I would walk up the stairs, right? In between them, right? And I'm teaching to a class of 150 business students, and I'm teaching them data analytics, and they're going like this, right? And then, if he walks up the steps, and I'm still continuing to lecture as if it's normal, it's just that I've left my prompt area, and I've gone here, and I've then, and then when I'm standing beside them, I'd say, so what did you think of that? What's the answer to that one? It's like that becomes more memorable for them, because what they do is they exit that lecture theatre and they go, do you remember he walked right up and he asked Elena what she said about such and such a thing? And so that is their things that I would do. I mean, I had thought of doing some juggling during the lecture in order to part. So they would remember the formula for linear regression because it was just after he did the juggling part. So, but it's not a circus. We haven't yet moved to post-produce the videos that we use in educational applications to make them more memorable. And even if it was an hour-long episode, what you would like to do is you don't want them, they don't need to remember the whole 1 hour lecture. There may be 2 or 3 or 4 or a number. So you want to make this part here. Now, this formula that I'm going to give you for linear regression, this is really important. So listen up here, every one of you, pay attention. So that's the part you want them to remember. So you want lectures' memorability to be a bit like an episode of CSI, a roller coaster of forgettable things, but a number of moments of standout Kodak moments that they will then recall. Yeah, we haven't done it for lectures though yet, Alisa. We're not there.
That would be very interesting. I think that possibly where the future is.
I would suspect. Yeah. And all of this, just to close the loop from where we started earlier on, all of these are new applications of computer vision which go beyond content analysis, captioning, object detection, compression. So when people, and I said this a while ago, I said, people sometimes think, well, computer vision, that's solved, we can navigate cars and we can do all sorts of things with the problem solved. It's not. There are so many other aspects of computer vision, like the memorability, which we spent the last 30 minutes talking about, for which we've only just scratched the surface of.
Let's quickly talk about, remember in the prep call, we were talking about how, there are new technologies to identify AI-generated videos from, AI-generated people from, humans, real humans. And you mentioned quite an interesting
the Euler, yes. Yeah, the Euler video magnification. Yeah, so deepfake detection was very popular about 2 or 3 years ago. Remember that? And then it kind of disappeared. And one of the things that the big tech companies, so I think Microsoft and Google and others were involved in it, was they ran a global deepfake detection challenge where they produced about, I think it was 700,000 videos, and they said half of these are real and half of these are fake, right? And they shuffled them and said, off you go, world, see what you could come up with. And there were thousands of participants. So again, this is this metaphor of taking, or sorry, this style rather of taking a collection of data, keeping the ground truth away from participants, making it available, have people do their own thing, and then submitting results. You know, there were about 3,000 and something participating groups who took part in this. We were one of the groups that took part in it. And the idea was to detect whether something is or is not a deep fake. So it was a binary decision. Is this video, you know, which might be 10 seconds of it. Our approach was to use a technique called Euler magnification. And Elisa, have you got the video of that you can throw up and share? So Euler magnification is a video post-processing technique which exploits very small differences, either in movement or in color in the real world, which carried into video, but which we cannot see. Now, if you can go to about 1 minute 32 as the offset within that. So I have skin, and what is happening to my skin is as my heart is pumping, boom, boom, probably 60 beats a second, what happens is that the capillaries in my face are flushing. They're getting redder, right, as a result of the pulsation associated with my skin. And the net effect of all of that is that in sync with my heart rate, my skin changes color, but it changes color to such a small difference in redness that the naked eye cannot see this. However, the changes in that pulsation do get encoded in the video. But even when we play back the video, we still don't see that pulsation. Euler magnification is a technique which takes a video and looks at a pixel, and then looks at that pixel in the next frame and the next frame and the next frame, and sees if there are subtle changes in the color or the intensity from frame to frame to frame. And if there are changes of maybe 1 or 2 pixel points or 1 or 2 shades of red, then what they do is that it magnifies that by 100 or by 150. Now, if you can drag the slider to about 1 minute 32, Elisa, that would help.
1 minute 32. Let me.
1 minute 32.
Yeah, it's a little lagging, I guess, because of 1:30.
So don't press the play button yet. So what we're seeing then is that what we'll see is a picture of a gentleman on the left is the original source, and he's just looking at the video, and you will not see any difference in the color of his face. But in the video on the right side, as we look on that, the color has been amplified 100 times. Now, if you hit the play button there, and I'm hoping it transmits okay and people can see this, you'll see it's okay. It's a bit laggy, but if you look at the original video on YouTube, you'll see it's as if he's getting embarrassed, red-faced, and then returning to normal. Embarrassed, red-faced, and then returning to normal. And it applies even for different colors and intonations of skin, this notion. And this is called Euler, E-U-L-E-R, magnification. And it applies to slight differences in color, and it also applies to slight differences in motion. If you drag the slider to about 3 minutes 20 now, Elisa. So slight movements of motion can also be amplified, not just changes in color. Yeah, that's perfect. Let that go. And you'll see the wrist. And on the right side, and the left side is the original, and in the right side it is magnified. And we've also taken and zoomed this in. This isn't our video, this is the original video. And you will see motion is amplified. In particular, with this baby, the original video is on the left. On the right, it's been motion amplified only times 10. And you'll see what happens is it looks as if the baby is breathing. Huge differences in his or her respiration. So this technique of Euler magnification magnifies slight and imperceptible to the human eye. Going back to the video and the deep fakes, our contention was that deep fake videos will not have hidden within them the pulsation that is as a result of our heartbeat. And then what we did was we applied Euler magnification to each of these videos to detect and to indicate whether it was an original one, in other words, it did have the pulsation, or it was a fake and it didn't have. And yes, we were able to detect. And in terms of scoring between the top scored result and the ones which are down at about 3,000, ours was somewhere in the middle. But the point was not that this is a great technique, this is the best technique, but the whole point of the deepfake detection challenge was that there were many different techniques developed and tried, and we all learned from the experience. So it was a contribution that this Euler magnification can work for deepfake detection, as can hundreds of other techniques. Ultimately, it's an ensemble of everybody's technique that would be used for the ultimate deepfake detector. Again, another application of computer vision.
What would I give for this technique back when my kids were just newborns? And you constantly had to check whether they're still breathing when they were like fast asleep, you know, when the child is sleeping so soundly, you keep checking whether your child is still breathing.
Yeah, and what you do have for that monitor is that you have an audio track, and you can hear the child if she or he gets into a cough, right, and starts to have a coughing fit. But you look at the monitor, and typically you look at the monitor on your phone, and you can't see whether she or he is breathing, right, because it's so small. It's so small and so subtle. And even if you go up to the room and you look in the cot, you know, you can't see that movement. But this sort of technique would have had a brilliant application in remote baby monitoring. We've actually used it in a hospital for early premature babies. So when a premature baby is in an incubator, you know, the last thing you want to do is to have to put another sensor on the baby, because it's another source of infection. But by remote Euler magnification, you can determine the pulse from the pulsation and the respiration from the movement. And these techniques are now used in high-end hospitals. It's not widespread enough yet, but it's an example of something that's being rolled out. And it means you don't have to put another sticky plaster and another sensor on the baby to see respiration and pulsation. So yeah.
This is incredible. I think that's a very uplifting kind of, I guess, note to, you know, to conclude our talk, because I think we're kind of a little bit over time, which I'm not surprised we are. This is such a fascinating topic. Definitely could take the entire semester to go
before we let Professor Smeaton go. I just have one more question. Do you always have juggling balls with you every time you are on the speaking engagement, or it's just for us?
No, it's regrettably and for disappointingly, which is not for you. They are juggling balls, but I have them here with me in my desk, and another pair at work, another set of three at work, because sometimes when there's things that really annoy you, there's nothing more satisfying than taking one of these things and going with it like that, and then you sort of, it's a tension release. So yeah, I don't use them for juggling because I can juggle only the one, right? But they're great for releasing the tension.
Wow.
Well, they're great. They're great for both, as we've already established today.
Yeah, there's another variety, sort of like a squishy ones, right? So where you kind of stress reliever. But I guess, I mean, if both techniques works, whatever works, that's fine.
Exactly.
Well, I'm personally very glad that Alan didn't use those balls today for their first kind of purpose, but for juggling. So thankfully we didn't annoy you enough for you to do that. Thank you so much for
Alan,
agreeing to be our speaker.
And thanking you for inviting me. I've really enjoyed it. It's been good fun. Good to meet you both.
Thank you so much, Alan. Bye, everyone.
Bye.